Hello families, we're going to talk about fractions today. So I'm going to start by talking about the numerator and the denominator. The bottom number that I have here is 6, that's my denominator. That tells me the total number of equal pieces. So if I look at this picture over here, I have a circle that was cut into 6 pretty equal pieces. When students are partitioning or cutting a shape into pieces, they're probably not going to be able to make it exactly perfect, but they should be able to make pieces that look pretty equal. So here I have 1, 2, 3, 4, 5, 6 equal pieces. I look at the denominator. That tells me the number of equal pieces of the whole that are being described. So in this circle right here, I have 1, 2, 3, 4 out of the 6 equal pieces being described because they're shaded. So I would say that 4/6 of this circle are shaded green. We also want to talk about the unit fraction for each figure that we can create. So my unit fraction is looking at just what each piece is worth. So if I'm looking at just this one piece right here, I would say that that is 1 out of 6 pieces, or I could call that 1/6. Here's another 1/6. Here's another 1/6, and I could go on the whole way, and after I count them all, I would get 6/6, or that's the same thing as saying 1/2, because I've counted the whole shape. Let's also talk about fractions on a number line. Students will be shown number lines, and they are going to be asked to partition or to cut the shape into pieces. This number line goes from 0 to 1. I could partition this into halves or 2 equal parts, thirds or 3 equal parts, fourths or 4 equal parts. I could do fifths, sixths, sevenths, eighths, and I could just keep going to however many equal parts I would want to do, but students are really going to go only pretty much up to 8. So to make it as easy and stay with the same denominator as our first page, let's say I want to cut this into 6. That means that I need to make 6 equal pieces. The easiest way for students to do this would be by finding the middle. They can think about this as a doubles math fact. So if I have my number line and I find the middle, I know I would need 3 pieces on this side and 3 pieces on this side. So I'm not going to start by trying to make my first piece down here where 1/6 would be. I'm going to start by cutting it in the middle, and this will help students partition it into equal pieces. I also know if I need 6 pieces, I need to draw 5 lines. So I have 1 here. Now over here on this half, I need to make 3 equal pieces. So I can kind of guesstimate where that would be. So I have 1 piece, 2 piece, 3 piece. And on this half, I need to do the same thing. I need another 3 pieces. So here's my other 2 lines. When students are finished making the actual lines, they want to count how many equal pieces or parts they have, not how many tick marks. A lot of students will make the common mistake of saying that this has 1, 2, 3, 4, 5, 6, 7 equal parts because they're counting the lines, and that is not what we want to do. So we take these jumps to show the equal parts. So there's 1, 2, 3, 4, 5, 6 equal parts, and then we're going to label them with numbers just so I can see and I'm very sure of my work. So this shows me that my denominator is going to be 6 because I cut it into 6 equal pieces. So if I wanted to show the fractions on the number line, I can then count. From 0 to this first tick mark is 1 out of 6 pieces, so 1/6. Then we go to 2/6. Then we go to 3/6. Then we go to 4/6. 5/6. And as we said on the last page, 6 out of 6 or 6/6 is the same thing as 1/2. We would say those are equivalent. If I thought about this as a piece of candy or like a hopscotch, I went 6 out of 6 pieces. That means I went the whole thing, one whole thing. So if I wanted to show 4/6 like I did on the first page, I could show 4/6, and that would be right here. It shows that we went 4 out of the 6 equal pieces. Students might also see fraction fractions that are greater than 1 whole. So this number line is different because I have from 0 to 2. I don't have 0 to 1. So when I make the half mark, that's not going to be half of 0 to 1, that's half of 0 to 2. So think about what is right between 0 and 2, that would be 1. If I want to still cut this into 6 sixths, that means I need 6 equal pieces in between each whole number. Students might think that they need 3 over here and 3 over here like we did before, but we're showing 6. So I need 6 equal pieces in between each whole. So I'm going to do the same thing I did on the last slide. I'm going to look from 0 to 1. I'm going to cut it in half. Now I know I need 3 over here and 3 over here. So these 6 are going to be smaller pieces, but they're still 6. So these might not be exactly equal, but they're pretty equal. Now from the whole number 1 to the whole number 2, I'm going to do the same thing. I find the half mark, and then I'm going to put 3 equal pieces on either side. And I can still count my jumps like I did on the last slide. So here's 1 equal piece, 2 equal piece, 3 equal pieces, 4 equal pieces, 5 equal pieces, 6 equal pieces. So this would be 6, 6. That means I went the whole. And then I can count the 6 again. There's another equal piece, 2, 3, 4, 5, 6. So between each whole number, I have 6 equal pieces, so I cut that into 6. When students count after the whole number 1, they could do that in 2 ways. After I say 6, 6, that means I've counted 6 pieces that are the size of 1/6. I would count 7, 6, 8, 6, 9, 6, 10, 6, 11, 6, and 2 is equal to 12, 6. Now an easy way to look at that is seeing that the numerator is double the denominator. So if I do 12 divided by 6, I get 2, which is where we are on that whole number. Another way students can say this is they can look at the whole number that they have, and then they can count how many extra 6 they have. So this piece right here could either be 7, 6, or we could call it 1 whole and 1/6. That means that 1 and 1/6 is the same thing as 7, 6. That means I went 1 whole number, and then I went this extra piece right here. I went an extra 1/6. So let's say I wanted to count right here 10, 6. I could either count that as 10, 6 or as 1 whole. I haven't gone 2 wholes yet, so 1 whole and 1/6, 2, 6, 3, 6, 4, 6. So I could also say 1 and 4, 6. Either way is fine. The last thing we're going to look at is fraction models. This is where students might be asked to partition a shape into different equal pieces. So let's take this circle and say I wanted to partition it into fourths. That means I need to make 4 equal pieces. And as I've been saying, they're not going to be absolutely equal, but students should try. So an example of me not showing equal pieces, this would be an unacceptable presentation of fourths, because this clearly doesn't look equal. This piece is a lot larger than this piece over here. This vertical line needs to go more towards the center. Students don't have to work with exact precision, but it should be better than what I just did right there. So if I cut that down the middle, right here, and then I can cut it horizontally, that shows fourths a little more clearly. So if I think about the unit fraction, each piece is worth 1 out of 4. 1 out of 4. And if I do that all the way around, I would have 4 fourths, or I would have the whole. If I wanted to cut the rectangle into fourths, I could do that in a few ways. We want to again think about starting with the middle piece. I could either find the middle horizontally or I could find the middle vertically. So if I find the middle horizontally, it's about here. Again, it's not going to be perfect, but it should be pretty close. And then they could cut it down the middle right here. And I have fourths. Another way students could do that. Ooh. There we go. Another way students could do that would be to cut down the middle, and then on this half they could again cut down the middle, and then on this half they could again cut down the middle. These fractional pieces look different, but they are all still equal to 1/4. We also want to look at fractions of a set. You could have a set of pretty much anything. You could have a set of animals, a set of shapes, a set of candies, a set of people. In this case, I have a set of stars. A set of shapes. So in this set, I have stars, I have triangles, and I have pentagons. Students might be asked what fraction of the shape are stars. So they need to express that as a fraction. They can't just count the number of stars and say 1, 2, 3 because 3 is a whole number and they want to know what fraction. So if I think about going back to my numerator and my denominator is the number of equal pieces. So in this case, it's the number of equal shapes in the set. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 total shapes. And the numerator tells us which part of the set that we're looking at. So in this case, I'm looking at stars. So now I want to name just the stars. So I have 1, 2, 3 stars. So to answer that question, I could say that 3/9 of the shapes are stars. I hope this was helpful, and if you have any questions, please let me know, and we can always make another video. Thanks!